Okay, so according to the circuit diagram that I drew, we have two 1 microfarad capacitors in series, which is basically connected to the LED. So right now I'm going to turn on, and then we can see that there was a little bit of current that passed through the capacitors, and that the LED glowed up for a little bit. Let's try this again. And this time the capacitor is charged. That's why the LED won't glow up. But as far as we saw, that there was a little bit of current passing through, and I can try turning on the switch, and then I can try switching this male wire to the positive side of the LED, and we can see that the LED glows. But if we do it here, the LED doesn't glow, means that most of the voltage is being used to charge the capacitor. So the capacitor is using most of the voltage. And so right now we're going to try and put the capacitors in series, in parallel, and see what happens. So right now we have two capacitors in parallel. This means that we should be having more capacitance, two 1 microfarad capacitors. So let's try turning on the LED right now. We saw that the LED glue up for a little bit, but it didn't last very long. So this means that current is flowing through the capacitor, and now we just need to measure the current in series, putting the two capacitors in series and measuring the two capacitors in parallel to see if there is any current difference, and then we can get a little bit closer to our hypothesis that current increases when the capacitors are put in parallel, and current decreases when the capacitors are put in series. So let's get to it.